In 1944, 3 American B-29 Superfortress bombers made emergency landings in Soviet territory. The B-29 was the most advanced aircraft in the world. It had pressurized cabins. It had remote-controlled gun turrets. It had sophisticated radar systems. It had analog computers for fire control. It was a marvel of American engineering. And now, the Soviet Union had 3 of them. Stalin's reaction was immediate. He ordered the aircraft to be studied. He ordered them to be copied. He ordered them to be copied exactly. Parafuso por parafuso, screw by screw. The Soviet leader understood that the B-29 represented a technological leap that the Soviet Union could not afford to ignore. If America had this technology, then the Soviet Union needed to have it too. But there was a problem. The B-29 was not just advanced. It was incredibly complex. The aircraft had been designed using American measurement systems. Everything was measured in inches. Everything was designed using American standards. The Soviet Union used the metric system. Soviet engineers would have to convert every measurement. They would have to adapt every system. They would have to understand not just how the aircraft worked, but why it worked the way it did. Soviet engineers began the process of reverse engineering the B-29. They took the aircraft apart, piece by piece. They measured every component. They studied every system. They tried to understand the logic behind every design decision. They discovered that the Americans had used materials that were not available in the Soviet Union. They had used alloys that the Soviet Union could not produce. They had used manufacturing techniques that the Soviet Union had never attempted. The task seemed impossible, but Stalin had made it clear that it was not optional. The Tu-4, as it would be called, had to be built. It had to be built quickly. It had to be built exactly like the B-29. Soviet engineers worked around the clock. Soviet factories were converted to produce the components. Soviet workers labored to assemble the aircraft. The conversion from inches to millimeters was not a simple mathematical exercise. The Americans had designed the aircraft using inches, and every component had been manufactured to tolerances measured in fractions of an inch. When Soviet engineers converted these measurements to millimeters, they discovered that the tolerances were incredibly tight. A difference of a few millimeters could mean the difference between a component that fit perfectly and a component that did not fit at all. Soviet engineers had to develop new manufacturing techniques. They had to create new machine tools. They had to train workers to work to tolerances that they had never worked to before. They had to understand American manufacturing processes and adapt them to Soviet factories. It was a monumental undertaking. But the Soviet engineers were not just copying the aircraft. They were learning. As they studied the B-29, they began to understand American engineering philosophy. They began to understand how American engineers thought about problems. They began to understand the principles that underlay American design. And they began to realize that American engineering was not just more advanced. It was fundamentally different. American engineers designed for mass production. American engineers designed for ease of manufacture. American engineers designed for reliability and simplicity. Soviet engineers, by contrast, designed for precision and complexity. Soviet engineers believed that a machine should be as perfect as possible, even if that meant it was difficult to manufacture or difficult to maintain. The B-29 forced Soviet engineers to rethink their entire approach to design. The B-29 showed them that it was possible to build an incredibly advanced aircraft that was also relatively simple to manufacture. The B-29 showed them that American engineers had solved problems that Soviet engineers had not even considered. The Tu-4 first flew in 1947. It was an almost exact copy of the B-29. The aircraft had the same dimensions. It had the same weight. It had the same performance characteristics. To all appearances, it was a B-29 built by the Soviet Union. But it was not. The Tu-4 was built using Soviet materials. It was built using Soviet manufacturing techniques. It was built using Soviet labor. The Tu-4 threw the American Air Force into panic. The Americans had believed that they had a monopoly on long-range strategic bombers. They had believed that the Soviet Union would not be able to build a comparable aircraft for years. But now the Soviet Union had a bomber that was almost identical to the B-29. The Americans realized that they had underestimated Soviet capabilities. But there was more to the Tu-4 story than just the aircraft itself. The process of reverse engineering the B-29 had transformed Soviet industry. Soviet engineers had learned American manufacturing techniques. Soviet factories had learned how to work to American tolerances. Soviet workers had learned how to assemble complex aircraft. The Tu-4 was not just an aircraft. It was a school for Soviet engineers and workers. The reverse engineering of the B-29 had another effect as well. It had shown Soviet engineers that American technology was not magical. It was not beyond their ability to understand or replicate. American engineers had solved problems using principles that Soviet engineers could understand. American engineers had made design choices that Soviet engineers could learn from. American technology was advanced, but it was not incomprehensible. This realization had profound implications for the Cold War. The Soviet Union realized that it could compete with America in terms of technology. The Soviet Union realized that it could build advanced weapons. The Soviet Union realized that it could match American technological achievements. This realization led to the Soviet decision to pursue advanced weapons systems. This realization led to the Soviet space program. This realization led to the Soviet nuclear weapons program. But the reverse engineering of the B-29 also revealed something else. It revealed the gap between American and Soviet manufacturing capabilities. The Americans could build the B-29 using assembly line techniques. The Americans could build thousands of B-29s. The Soviet Union, by contrast, could only build a few Tu-4s. The Soviet Union did not have the manufacturing capacity to build large numbers of advanced aircraft. This gap would persist throughout the Cold War. The Soviet Union could design advanced weapons. The Soviet Union could build advanced weapons. But the Soviet Union could not build them in the quantities that America could build them. The Soviet Union could not maintain them as easily as America could maintain them. The Soviet Union could not replace losses as quickly as America could replace losses. The Tu-4 was a triumph of Soviet engineering. It was a triumph of Soviet determination. But it was also a reminder of Soviet limitations. The Soviet Union could copy American technology. But the Soviet Union could not match American production capacity. The Soviet Union could match American design. But the Soviet Union could not match American manufacturing efficiency. This lesson would shape Soviet strategy throughout the Cold War. The Soviet Union would focus on building fewer, more advanced weapons. The Soviet Union would focus on quality over quantity. The Soviet Union would focus on achieving technological breakthroughs that would offset American quantitative superiority. But this strategy had a fatal flaw. In a war of attrition, quantity always defeats quality. And the Cold War, though it never turned hot, was ultimately a war of attrition.
This is one of the wars that changed the world.